All right, so there are two kind of big things that we need to get through today. The first is compound inequalities, and then the second is absolute value equations and inequalities. A lot of this will be review, but let's do it. Compound inequalities just mean like, okay, there's two or more inequalities written in the same problem. And so when we're graphing them or showing where the solutions are, um, you'll have to think about how they interact with each other. And so it's important to tell whether it says and or if it says or between them, because those words mean different things in English, but they also mean really specific different things in math. And so the word and in math means both have to be true. And the word or in math means one, but not both. So it could be one, it could be the other one, but it cannot be both. So that's the important part about what or means. So let's just take a look at what these look like on the graph really quick. So here is a number line. This is where 5 is, and here's where -4 is. See, it's perfect. That puts 0 right about here or so. Here's the inequality that says x is less than 5, like that. And here is the inequality that says x is greater than or equal to 4, -4. So here's the question, where are both inequalities true? Well, both inequalities are true right here. They're both true there, so we can put a dot here. They're all both true until I get all the way over there, and all of a sudden, now the one that's written in black is not true anymore. So we have to have an open circle there, and then we connect the two inequalities. So what you need to do here is you need to graph both of the inequalities, show where both of the solutions are, and then use some thinking to be like, where is it true that both of them work? Where is it that they don't work? So notice over here, right here, the blue inequality is still true, but the black inequality is not true anymore. And so because of that, both are not true. So then that green spot right here is not in the solution. So the yellow inequality with the two dots, one of them is filled in, one of them is open. This is the solution there. On this one says both, or sorry, one needs to be true, one or the other, but not both. And so again, we're gonna draw our number line and just kind of sketch what this thing would look like. Here's where 4 is, here's where 7 is. This inequality looks like this, and this inequality looks like this. So where is one but not both true? Well, it's just the parts that are separate. So the solution is this black set of inequalities right here. So one of them is true here, not both. One of them is true here, not both. Neither of them is true here, so there's no line there, so that makes sense. One of them is true here, one of them is true here, one of them is true here. So all of the combinations work. Where it gets a little bit tricky is if you have a little overlap, but we're not going to see a lot of that this year. This is something that we're kind of skipping a little bit this year, is how to interpret when there's overlap. So we'll move on. I just have two examples here, so I want you to try this one first, and then I'm going to go through it. Okay, so since this is an or, I'm just looking for the area where one or the other is true and not where both are true. So let's find where this one is true. So first let's solve for x. So -3, -3. 2x is greater than or equal to -2. Divide both sides by 2, divide both sides by 2. We get x is greater than or equal to -1. So let's say 0 is right here. -1 is right here. the area where x is greater than -1, greater than or equal to -1, is that side. Over here, let's do the same thing. Let's solve for x. So -5 minus 5. So -3x is greater than, now I have 9 here. I divide both sides by -3, but when I divide both sides by -3, we have to reverse the inequality. So now x is less than -3. So here's where -3 is. It's not equal to, it's just strictly less than. So that's this part of the inequality. And so now where is one but not the other? Well, it's both parts of this. The only part that isn't shaded is 3 through here. And all of those are not solutions to this compound inequality. So what I have written, what I have drawn here works. This one is an and, so both have to be true. I want you to try this one first and then I'll go through. Okay, so let's get x by itself on this side. So -1 minus 1, we get 6 is less than 2x. Divide both sides by 2, and I get 3. Whoa, 3 is less than 2x. Okay, 3 is less, just kidding. It's not 3 is less than 2x, my bad. It's just 3 is less than x. Okay, so just be careful here, because if my boundary is at 3, I have an open circle. Where is it true that 3 is less than x? Well, the values that work here are over here. And so I need to, over here. And so I need to draw my arrow that way. If you're stuck on that and you're more comfortable writing it the other way where the x is written first, x is greater than 3. Notice that these two are interchangeable. Okay, so then on this side, we need to divide both sides by 3 over here. We get x is less than or equal to 6. I just got to remember how to divide. Here's where 6 is. X is less than or equal to 6. I'm more comfortable with this one because the x is written first. Okay, now the question is, because this is an and, both must be true. And so we have to find the area where both are true, both inequalities work. It's not right here because there's an open circle for the red one, but it's all of this, and then it includes 6 right here. So that's the part of the graph that works for both inequalities. This is not something you're going to see a whole ton here, but I just wanted to expose you to the fact that if you have a 3-part inequality, and when I say 3 parts, I just mean 1, 2, 3, there are 3 parts there, you can rewrite these as and inequalities. This sort of makes sense. It just says x is between 5 and 10. X is between -2 and 6. So it makes sense that x is greater than -2, but x is also less than 6. So this is it just sort of makes sense what it's saying. But I just wanted to say that this is also another way of writing an and inequality. This is the interesting part of today. This may be a little bit new. Hopefully you've seen absolute value before. Absolute value, remember that absolute value is defined as the distance from the zero, from 0. So here's where 0 is. If the absolute value of this stuff is 5, then that means that this stuff is 5 units away from 0. And so, therefore, we could have it be 1, 2, 3, 4, 5 units away from 0. But we could also go 1, 2, 3, 4, 5 units away from 0. And so what we have here is we have 2 things that can happen. 2x minus 1 could be there. It could also be here. And so we have two different things that are happening here. So if 2x minus 1 is 5 units away from 0, then 2x minus 1 has to be either 5 or it has to be negative 5. And so what we do is we split up the equation into two separate cases, and we say, well, it could be this or it could be this, and you have to find both solutions and see if they work. So what we're going to do is we're going to set up two different equations. We're going to say 2x minus 1 equals negative 5, and we're going to say 2x minus 1 equals positive 5, because we want to reflect that both of these options give you something that is 5 units away from 0. So then, we just have to solve these two equations. These are both two-step equations. We should be really familiar with these, but let's do it. We get x is negative 2. That's one solution. And then we're going to add 1. We get 2x equals 6. Divide both sides by 2. And I get x is 3. Whoa, okay. So now I have two solutions. And what I need to do is I need to check to see if they work. Especially with these absolute value ones, sometimes we get what's called an extraneous solution, and an extraneous solution is just an extra one that doesn't actually work when you put it back in the original equation. So we need to take these solutions and put them back into the original thing and see what we get out. So let's put in 3. 2 times 3 is 6. 6 minus 1 is 5. The absolute value of 5 is 5. And so this one works, yes. Let's put in negative 2. Negative 2 times 2 is negative 4. Negative 4 minus 1 is negative 5. But the absolute value of negative 5, remember, is 5 because it's 5 units away from 0. And so both of these solutions work, and we're done with the problem. Okay, so this is one of those ones where you need to really be careful about your checking your extraneous solutions, especially when there's an x on both sides of the equation. But here's what we're going to do. We're going to do the same idea, but here's where 0 is. And now what I'm going to say is, well, we want this stuff to be 3x plus 4 units away from 0. But, so it could be the positive 3x plus 4 away from 0, or it could be the negative 3x plus 4 away from 0. So we're trying to explore both options where we're that far away from 0, because that's what absolute value says. It's a distance from 0. So we could say 2x plus 5 is equal to negative 3x plus 4. Or we could say 2x plus 5 is equal to positive 3x plus 4. Be really careful about your negatives here because you have to distribute that negative through. And so what we end up with is 2x plus 5 equals negative 3x minus 4. When I solve for x, remember, whatever you do, you just have to do to both sides. It doesn't really matter. You're trying to get x by itself. We get 5x plus 5 equals negative 4. We're going to subtract 5 from both sides. We get 5x equals negative 9. Divide both sides by 5, and we get x equals negative 9/5. So there's one solution. We're going to have to check that in a minute, but let's get the other solution. This time I don't have any distributing. I'm going to subtract 2x this time, just to see what happens. 5 equals x plus 4. Then I need to subtract 4. And I get x equals 1. Okay, so now what I need to do is in the original equation up here, I need to put in these values and see what I get out. So this is going to be a little bit tricky because I got an ugly answer, but we can do this. So Let's see what happens when you put negative 9/5 in. Absolute value of negative 2 times negative 9/5 plus 5 equals 3 times negative 9/5 plus 4. I put the question mark there because I'm trying to say, does this actually work or does it not work? I have to test it to see if it's happening or not. So I would encourage you to use your calculator here just because this is a little bit intense. This is a little bit annoying. So let's just go for it. So I'm going to pull up my Desmos calculator. And I'm just going to type in this whole thing over here. So absolute value is this button right here. So then I do 2 times negative 9/5 plus 5. So we get 1.4. Over here, we're going to do 3 times negative 9/5 plus 4. And we get negative 1.4. And since these two things aren't the same, this is not an equals sign. And so we have to say this is not equals. So this solution is what we call extraneous. Now, let's do the same thing in Desmos, except let's change the negative 9/5 to 1, because that's the other solution that we have. So we'll just delete that. And change it to 1. And then we got to change this one to 1 also. And this one should be a little bit clearer. This one is for sure going to work. Okay, so they're both positive 7. And because they're both positive 7, that tells me, okay, this is actually a solution. So this one we can confirm. So our only solution here is x equals 1. Just make sure that you're checking your work in the original equation. That's all I'm trying to say here. Now in this one, we have an inequality working with absolute values. So I know that now we're kind of putting together two ideas here. I want to think about what this looks like on the graph first, and then we'll go for sort of how to go about the algebra. So what this says is the absolute value of this stuff is less than or equal to 2. Remember that our definition of absolute value is the distance from 0. And so if here's where 2 is and negative 2, we could say, well, the distance from 0 of this stuff is less than or equal to 2. And so 2x plus 1 has to be between these two values. So we can say, you know what? 2x plus 1 is between, 2x plus 1 is between and including, because it's or equal to right here, 2, but it's between negative 2 and 2. So now we have a three-part inequality, and we can split this up, as I said earlier. You know what? That we can split this up into an and. So we can say negative 2 is less than or equal to 2x plus 1. And we can say and 2x plus 1 is less than or equal to 2. So let's solve for x. So like that, divide by 2, and I get x is greater than or equal to negative 3 over 2. That's 1.5. It's the same as 1.5. Over here, minus 1, we get 2x is less than or equal to 1. Divide by 2, we get x is less than or equal to 1/2. So our solution, this is, let's say 0 is right here. Let's go by 1. So 1, 2, 3, negative 1, negative 2, negative 3. Okay, so where is negative 3 over 2? It's 1.5. So that's right here. And 1/2 is right here. And so since x is greater than negative 3/2 and x is less than 1/2, this is our solution. So this entire inequality looks like that. So if you put in any of the values that are represented by this black inequality into this, you will get a true statement. Okay, this is a greater than inequality, and what I'm going to do is I'm going to start by just getting the stuff that's inside the absolute value by itself, and then I'll let you finish the problem by yourself. So I'm going to divide both sides by 3. And I get the absolute value of 2x plus 12 is greater than 32. So here's what this is saying. Whatever is inside the absolute value, the distance from 0 is greater than 32. So here's where 0 is. Here's where 32 is. Here's where negative 32 is. 2x plus 12 has to be over here, or it's got to be over here, because it's further away from 0 than 32, or negative 32. So now we have two inequalities to set up and then solve. So 2x plus 12 is less than negative 32, and 2x plus 12 is greater than 32. You can solve these two. Here's what we get. We get 20 here, subtracting 12 from both sides. Okay, so then we get 2x is less than negative 22. Sorry, just kidding. It's x. Divide both sides by 2. We get x is less than 22, negative 22, and we get x is greater than 10 over here. So here's where 0 is. 2, 4, 6, 8, 10. So x is 10. X is greater than 10 is this inequality there. X is less than negative 22, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Like that. One more for you to try here, and then I'll go through it. Okay, so let's divide both sides by 4. And I get 2x, the absolute value of 2x minus 15 is less than or equal to 7. So 2x minus 15 is closer to 0 than 7 is. So here's where 7 is, here's where 0 is, here's where 7 is, and here's where negative 7 is. 2x minus 15 is between here and here. So we need to say, okay, 2x plus 15 minus 15 is less than or equal to 7. That's what this part of the inequality is saying. And I know I wrote this a little bit backwards, but 2x plus minus 15 is greater than or equal to negative 7. So that's this part of the inequality. Solve that, graph that. I'm not going to go through this because I don't want to make you watch all of that on the video. On the next 2 slides, you're going to see some instructions for the rest of the day, but I just wanted to show you, if you go to this slide that looks like this, you'll have to click right here to go to the textbook. There's also instructions on the lesson assignment. I want you to try these book problems just to get practice seeing the book, working with the book. We're going to be using it in the future, but also because it's good practice. Your username for the login is going to be your entire isd282.org email address, and then everyone's password is Huskies20 this year. I'm not asking you to turn these in, but I am asking you to try them. I want you to do as many of them as it takes for you to get confident about doing these problems.